Morning, everybody. Ooh, all right, that's loud. It's good at 8 o'clock in the morning. All right, welcome to the storage track for the OCP Summit 2019. We have a few talks this morning, then we have the break for the few hours, and then we'll come back here in the afternoon for a few more presentations. So without further ado, Tim, James. I think you're ready.
Okay.
Now I'm ready.
Yeah, this morning we're talking about Seagate's dual actuator technology, and specifically, since we've been working on this product for a while, we've been working with several customers, and we're getting close to productization, and we have a lot of lessons learned, things we have learned about. And I should probably start off by introducing ourselves.
You should, yes, James.
Yeah, I'm James Borden. I work for Seagate in the product line management group, focusing on cloud customers, hyperscale customers, and driving new product deployments for future technologies. I work with SMR, I work with dual actuator, and I work with other several innovations that Seagate's been developing.
My name is Tim Walker. I'm a principal engineer working for Seagate Research. I work with our major customers in helping them integrate our new technology into their systems, supported host managed SMR into the data center for the last few years, and dual actuator as well.
We have 20 minutes, right?
No, we have 18.
18 now, that's right. The whole concept of dual actuator, is something Seagate's been thinking about for a long time. As we've been working with our hyperscale customers, we've been noting that they've been getting issues of stranded capacity, and a couple of our major customers came to us looking for solutions for stranded capacity, and how they can handle that. I mean, some of the specific things people do today is they'll short stroke the disk drives is one of the major ways to do it. And so on this chart, which I can't see well, I mean, the basic problem is, our HDD capacities are going up, whereas the transfer rate on these disk drives is remaining static. And as at a certain point, as the capacity is increasing and the IOPS per terabyte is going down, given a consistent transfer rate, these lines are crossing. Now, for different customers, there are different capacities. IOPS per terabyte, we've seen some customers with as low as 5 or 6 IOPS per terabyte running out of ability to deploy larger capacity drives. Some customers are able to go 10, 12 IOPS per terabyte, which allows them to go to a slightly higher capacity, but almost everybody's recognizing that as these drives are getting bigger, one way or another, these companies that are deploying the high capacity drives are going to hit a wall. And without a solution to that, they're going to have trouble deploying, which means instead of being able to go deep with high capacity drives, they're going to have to go wider, basically adding more drives at a certain capacity and adding more slots, more clusters, and that's getting a lot more expensive. And for the HDD business, it becomes less attractive because the relative cost of HDD deployment compared to flash gets a little bit closer, and our whole object in spinning media is to drive TCO down. To drive TCO down, we're looking at implementing basically dual actuator drives.
So this is really the last time we talk about performance in this briefing specifically. And so I'm going to point out that Broadcom has been one of our partners on this project, because obviously with the architecture you see coming up, the interface, the host bus adapter was a key part in deploying this. And Broadcom has produced a white paper jointly with Seagate, and we have, if you take it, put it in your bag on the way out. We have a bunch on the back chair. It's really nice white paper. Patty Kim wrote it. It's obviously expertly done and lots of colors. So.
Yeah, and what we're trying to do with dual actuator is get rid of this gap and flip it, where the IOPS per terabyte ability on the drive is greater than the IOPS per terabyte SLA on the drive. And that's where dual actuator came. Yeah, enter. And the best way to solve this is to either add faster transfer capability, which is very difficult in spinning media, or add parallelism, which is what dual actuator is. It's basically having two active actuators, two active data channels, two different channel and servo mechanicals, and going each to half the platters on the drive. So we have, whereas normally you have 8 platters on a drive of a single actuator, we have split that actuator to address the bottom 4 and the top 4 spindles separately as separate actuators and data paths. And this manifests as 2 different LUNs. It's a SAS implementation. We discuss with customers about SATA, but the SATA implementation is a little bit more difficult because it really doesn't have capability of being able to separate LBAs cleanly without a lot of stack work. With SAS, this is pretty much drop and go. There's no real changes to the SCSI stack or to within SCSI standards T10. And these drives are exposed as 2 separate LUNs, looks like 2 separate drives. And basically will deliver 2 drives like performance.
So what we really wanted to talk about today is kind of what we've seen in doing the system integration work. And the title of our slide is Best Practices, but really the title is Good Practices. We're still learning a lot about how the dual actuator drives integrate into customer systems. Even though when you install a dual actuator drive into a SAS-based system, really every OS and every HBA combination that we've tested, it comes up, shows up as 2 LUNs, OS registers 2 devices, and it really does work. For like basic benchtop testing and everything, it works right out of the box. But when and then I want to kind of break it up into different ways that our customers use these drives. In this case, for our customers who do not use file systems, who manage the on-disk data layout themselves, some of the things that we have learned is that we have to be very careful to differentiate between the 2 data paths and the 2 control and management paths, because these drives share, the 2 LUNs on a drive share common management path. The spin up and the spin down, the power levels, write cache enabled, all the things that we're accustomed to configuring on a hard drive. A good percentage of those extend across the device to both LUNs on the device, but partially due to the fact that it is 1 device with 2 sets of LUNs, and partially because it has been more reliable and more convenient to put it together that way to get a higher quality product out sooner. And then one of the things we have to watch for as we're integrating the system, if we want to get the performance increase that we expect, is whoever's doing the on-disk data layout has got to keep in mind that since the actuators are split and they're presented as 2 different LUNs, things like balancing the workload across these 2 LUNs is up to us, as integrators. The drive does not have the capability, and nor do our customers want it to, for you to feed it 1 data stream and for the drive to divvy up the data across the 2 actuators, and balance itself. Our customers don't trust us to do that correctly, and so they believe they can, and they're right, they know their data, they would prefer to control where the data is placed on the drive. So since we've given them those knobs, it's very important that to keep in mind that if you really, if you want to get 1.8, 2x performance out of these, which they really are capable of doing, it's important to make sure we have enough workload entropy across the LUNs to keep both LUNs busy. Any questions so far?
Yeah, do you do striping across the LUNs in the device?
You can. That's what I do when I set them up. But the drive itself does not. So, like if you walked by one of our demos out in the exhibition hall, we've done.
Restate the question because I don't think everybody heard.
Oh, the question was, can we stripe the data across the LUNs? I think that is a really, I think for out of the box, really good performant solution, that is a great way to do it. And what I've been doing for a lot of our demos and to show people how they work is, like, for example, under Linux, is set up the device mapper to stripe across the two LUNs on a given device. And that works real well. And on the Windows side of the house, what we have been using for our reference architecture for a Windows server is storage spaces, and setting up storage spaces as, I normally just use like this simple striped volume, but there's other options for storage spaces to distribute the data across a set of actuators or LUNs. And letting the systems do it, just really treating them as you would individual drives. We have to touch on reliability just for a second. How's our time, by the way? There's no clock in here. We have to be careful because RAID, that's the one question that come up. And we've been doing a lot of work with our HBA partners, actually with Broadcom, and about how to deploy these in a RAID device, because on any given drive, we got these two LUNs, but those LUNs really don't represent any kind of significant failure domain separation. They are the same failure domain by any reasonable level of failure analysis. So for software-defined storage or for hardware RAID, the key is keeping the LUNs that are on the same drive out of the same redundancy group, because if that drive goes down, you're going to lose two. You're going to lose both LUNs. If both those LUNs are in a given redundancy group, then you don't have the redundancy that you thought you had. In this case, right now, this is our go-forward approach on RAID, which is just a RAID 50. I don't think we're going to go through all the steps to build this in the time that we have. I think that this should be pretty straightforward to everybody in this audience. Is there a question about how the RAID approach? The RAID approach works well on these.
I mean, the important thing in the operating system is to recognize that these LUN associations on a physical device and treat them accordingly. If you're doing spin-ups, spin-downs, management, and you're communicating through one LUN, you have to be aware of what the other LUN is. And there's some mechanisms being put in place in T10, I guess it's through a mode page, that will tell you the associated commands that you need to be aware of. And but what is not there is any stack implementations where these LUN associations are basically tied together up the stack. So there's a little bit of work and awareness that has to be done, but it's not a big lift.
Hey, Tim. Another question just around related into this. From an HBA supplier in partnership with Broadcom, as you mentioned, it's pretty much, it works right out of the box. So no hardware implications as you see it for any customers going forward. It will be perhaps some software, even on the legacy products, so you're not forcing something to be infrastructure.
That's right. So for a software-defined storage application where you're using an HBA.
Repeat the question.
Oh, sorry. The question is for RAID. Let me summarize the question. RAID HBA support. What kind of HBA do I need, I think is what you're at. You know, what HBA software or silicon changes will be driven by this architecture. So that's two answers to that question. One is for the software-defined storage folks who are just using the HBA and IT mode, you know, just to present a bunch of LUNs. No, that works fine. It has always worked out of the box. With our investigation, we have done most of our work with Broadcom because Broadcom and us and our major customers, we're common. You know, Broadcom was one of our common partners supplying, for example, like Microsoft, and so they come up for software-defined storage work. It comes up fine, no changes needed. For hardware RAID, we are not there yet, and I don't really know. I'm not a Broadcom person. We've met with Broadcom, and we have, you know, and Broadcom and us, you know, worked on this scheme as an option, but to my knowledge, we haven't decided, or Broadcom hasn't decided, what the long-term way to do a hardware RAID implementation
Tim.
with this. Okay, so James said I have to stop talking and keep moving. In the Linux and FreeBSD side, we kind of mentioned this already. We just setting up a good quality striping and mirroring configuration. But really, you're going to set up your stripes and mirrors the same way we did with the hardware RAID, just on the software side. Again, it's important. The same points, same 3 points are always important in every one of these things. Watch your failure domains. Just because they're two LUNs does not mean they're independent. Watch the workload. Make sure that your workload has got enough entropy on it, so you're using the LUNs, so no LUN is idle. And then this is just, you know, normal storage architecture layout, good practices. Make sure that you have your data spread out, you know, all those things. That one is really not unique to dual actuator. How we're doing in our storage spaces? Storage spaces is easier but more complicated, because really you can, and this is what I do, you can put these in a J2010 and you can click right through on setting them up, set them up, boom, it runs and it's performant. But currently on managing a failure, again, back to failure domains again, I haven't gotten to the point where I don't believe yet that I have configured my storage spaces implementation to allocate the LUNs correctly to ensure that I have the durability that you think we should have. And it's no doubt my fault. Calls to action. So for us, we're continuing to mature the architecture of the device, and so are our competitors. We had, you know, some of the glitches are. This is, you know, there are shared resources on the device. We have to make sure the shared resources on the device don't cause contention and hurt our performance. For the vendors and stack developers, what we've learned is that many people just informally think of drives, LUNs, devices are equal. And in, you know, up for the last who knows how many years for direct attached storage, it's been totally true. It's not true anymore. So we have to watch our terminology, we have to watch how we name our variables, we have to watch how we write our documentations for setup, et cetera, to make sure that we can be very careful that we refer to the different subparts of this. And I'm going as fast as I can. And then we'll read the rest. Any questions?
You keep talking about dual actuators, and your proposal says multiple. What's the difference?
The difference is that there's the dual actuator.
Repeat.
Oh, sorry. I keep talking about dual actuator. My proposal says multi-actuator. Well, dual actuator is a subset. It's the first multi-actuator device that we've produced. I don't really know that much about. I don't talk about the project roadmap in public because it's not my end of the business. But what dual actuator is, this is my favorite soapbox to get on. Dual actuators for hard drive manufacturers to take what they really do the best and leverage it, which is heads, actuators, voice control motors, servo, which we do the best. And dual actuator lets us leverage that and keep hard drives more useful to our customers for longer. And that technology, there's nothing about that technology that keeps it from leveraging further from more than 2 actuators. And what direction it's eventually going to go, there's a lot of discussion, and I don't know how it's going to end up.
All right. Thanks, Tim. Thanks, James.
Thank you very much.
Thank you.